Hi, my name is Hannah. Today I'm going to be working with chapter 3, number 35. The question says, a pine cone falls straight down from a pine tree growing on a 20-degree slope. The pine cone hits the ground with a speed of 10 meters per second. What is the component of the pine's impact velocity? A, parallel to the ground. B, perpendicular to the ground. So we're asked to find the x and y components of the impact velocity. Here I drew a diagram to clear out the situation. So we have a slanted ground which is at 20 degrees and there's a tree, and the cone is gonna drop straight to the ground. When it hits the ground, it's gonna have a velocity of 10 meters per second. So we're gonna deal with a rotated coordinate system, which is like this. And then I zoomed out the final velocity as it hits the ground. And it is gonna be the x component, and this is gonna be the y component, which is parallel to the ground, and the y component, which is perpendicular to the ground. So we're asked to find the impact velocity. As this is a free-falling object, the impact velocity, which is the maximum velocity is going to be as it hits the ground. So we're basically asked to find the components of the final velocity. So the knowns are the final velocity, which is 10 meters per second, the initial velocity, which is 0 meters per second, and theta 20 degrees. We're asked to find the y component and the x component. For part A, we're going to use the sine function, which is opposite over hypotenuse. So we're going to plug in what is known, and we'll solve for what is unknown. So the final velocity in the x direction, which is parallel to the ground, is going to be 3.42 meters per second. For part B, we're going to use the cosine function, which is adjacent over hypotenuse. So we're going to plug in the known, cos 20, and the final velocity 10 meters per second. And the final velocity perpendicular to the ground is going to be 9.39 meters per second. And that's it. Thank you.